ray optics. First question. So size of the candle is given 2.5 centimeter. Object distance is minus 27 centimeter. Radius of curvature of the curve of the mirror is 36 centimeter. As it is a concave mirror, then its radius of curvature will be minus 36 centimeter. Focal length f is equal to r by 2. We will get a minus 18 centimeter. And you are asked to find the nature and size of the image font. Nature and size of the image font. Nature and size of the image font means you have to find the image distance, and nature of the image means mainly it is the magnification, linear magnification you need to find. And for linear magnification, you know, the formula m is equal to minus v by u is the formula. Okay, so there first you have to use mirror equation. Okay, 1 by f is equal to 1 by f is equal to 1 by u plus 1 by v plus 1 by v. Then you find the value of v. Even v you can find out using this formula. Find the value of v. You will get the answer around minus 54 centimeter. Minus 54 centimeter. Then you find the value of m using the formula m is equal to minus v by u. And you know, if m is negative, then it is a real image, and if m is positive, then you will get a virtual image. Okay, so you find the value of v, and you will get a minus of minus v divided by minus u. So definitely you will get a negative value. Negative value means the image is real, inverted. And if magnitude of m, mod of m is greater than 1 means it is enlarged image, otherwise it is diminished image. Here you will get a concave mirror. Okay, so then you have to find the value of m, and you will get around minus 2. You will get as m minus 2. So again use the formula m is equal to h dash by h dash by h, so that the image height h dash you can calculate, and h dash you will get around 5 centimeter. That means you will get an enlarged image. Okay, and the last part of the question, if the candle is moved closer to the mirror, how the screen have to be moved? So if the object moves towards the mirror, means image moves away from the mirror. So answer is the screen has to be moved away from the mirror. Okay, away from the mirror. So that is the solution of the first question. Now come to question 2. Question 2 is again a similar question only. Question 2. Height of the needle is given, object distance is given, focal length of convex mirror is given. As it is a convex mirror, focal length you have to take positive. Then here also again what you have to do, describe what have, okay, sorry, give the location of the image. Okay, so nothing more, you have to calculate it using the formula 1 by f is equal to 1 by u plus 1 by v. That is mirror formula you have to use and find the value of v. Okay, then once you get the value of v, You have to find the value of M to describe the nature. Magnification, you are asked to find magnification formula, M is equal to minus V by U. So find the value of magnification here, which is a convex mirror, so you'll get a positive magnification. And of course, it is a diminished image. Now, the last part of the question, describe what happens when the needle is moved farther from the mirror. Needle is moved farther from the mirror. So, when the object is at infinity, image is formed at the principal focus. And other than infinity, any other location, the image is between principal focus and pole of the mirror, because it is a convex mirror. Image is always between principal focus and pole. Now, if you move the object away from the mirror, what happens to the image? The image moves up to principal focus, or we can say the image approaches principal focus, because image can be formed only between principal focus and optic center. So when you move the needle farther from the mirror, the image moves towards the principal focus. Okay, so that is the answer to the second question. Now, third question, a tank is filled with water of 12.5 centimeter, that is actual depth, and the apparent depth of a needle lying at the bottom of the tank is measured by a microscope to be 9.4 centimeter, that is the apparent depth. Okay, now what do you have to do? Refractive index. Refractive index formula is there. Refractive index N is equal to actual depth divided by apparent depth. So actual depth divided by apparent depth. So directly you will get the answer. Okay, actual depth divided by apparent depth. Okay, that's the first part. Now come to the second part. If the water is replaced by a liquid of refractive index 1.63, and is given for the liquid 1.63 up to the same height, that means actual depth is same. What distance would the microscope have to be moved? Okay, so you take a 1.63, that is the refractive index, is equal to actual depth. The actual depth is remaining is 12.5 centimeter divided by, we don't know what is the apparent depth in the new medium, so you take it as x. Then find the value of x. From this equation you can find the value of x. Once you get the value of x, the microscope is already fixed for 9.4 centimeter, and from there what distance you need to move it, that is a question. So what you have to do, you have to calculate the distance moved is equal to distance moved is equal to initial adjustment, that is 9.4 centimeter minus x. So you will get the answer. Okay. Now, next question. Diagrams are given. You are asked to calculate the angle of refraction in the third diagram in glass. Okay. So here, this angle, there is a correction. This angle you have to take as 41 degree to get the answer. Okay. Now, how to solve? So the first case, first medium we will take. In the first medium, you can take a refractive index of glass with respect to air. NGA you can calculate. NGA is equal to, when you calculate refractive index, always The angle in the other medium you have to calculate. You have to take in the numerator according to Snell's law. So you will get NGA is equal to sine 60 divided by sine 35. Then next case you take a NWA, refractive index of water with respect to air. So refractive index of water, so you will get a sine 60. Again, angle in the other medium must be in the numerator. Sine 60 divided by sine 41. Sine 60 divided by sine 41. Okay. Now third case, okay, we don't know this angle, so you take this angle as x. Take a refractive index of glass with respect to water is equal to, what do you get, a refractive index of glass with respect to water, so you will get a sine 45 divided by sine x. Sine 45 divided by sine x. Now, you know, NGW, refractive index of glass with respect to water, is equal to NGA divided by NWA. NGA divided by NWA. Now you substitute the values of NGA, NWA and NGW in this formula. Then find the value of sin x. From the value of sin x, you can find the value of x. Okay. So that's the calculation. The question is an important question. Okay. Now next, question number 5. Question number 5. A small bulb B, you can see in this diagram. Okay, small bulb B is placed. So what happens? From the bulb, okay, the beam of light traveling upwards, and bulb is placed under water. So what happens? On the surface of water, you can see a circular part is illuminated. So here you have to understand very properly what happens there. Suppose the light falls on the surface more than this angle I. This is angle I. Okay. And here you can see in this diagram what happens to the light when it falls at a particular angle I. That angle is actually IC, critical angle. So that here angle of refraction is 90 degrees. Now assume that the light falls with an angle more than this, more than IC. Then what will happen if it falls with an angle more than IC? Then you know light travels from denser medium to rarer medium, and angle of incidence here is greater than critical angle. So here angle is greater than critical angle, so the light will undergo total Indian reflection. So then what happens? You will not get any emerging light outside. Therefore, if these angles are critical angles, here also critical angle, then you can imagine like that you will get the light emerging out from the water surface from this cone. Three-dimensionally you have to take from this cone. So what happens? A circular portion of water surface will be illuminated. A circular portion as the cross section of a cone. A circular portion is illuminated. And you are asked to calculate what is the area of that circular portion. That is the question. Hope you understood that. Now that area, you know, radius of the area R is equal to AC by 2. So this area, it means OC or OB. Okay, if you can find this radius, then area you can calculate. So that is the question. Now how can you calculate that one? Okay, so first of all, in the question you have refractive index of water is given. So use the formula n is equal to 1 by sine IC. N is equal to 1 by sine IC. Okay, from that equation, you can calculate the value of angle IC. Find the value of angle IC. Once you get the value of angle IC, then you find tan IC. You take that triangle OBC. From triangle OBC, you find the value of tan IC. Tan IC is equal to, it is OC divided by, OC I am going to take as radius R, OC divided by OB. OB is given, I think, 80 centimeter. 80 centimeter means 0.8 meter. So from that you can calculate the value of R. Okay, you will get the value of R radius. Once you get the value of R, then area you can calculate using the formula pi r square. Okay, use pi r square and calculate the area. So that way you will get the area. Okay, now next, take the next question. Okay, question number 6. The prism, unknown refractive index. Okay, then angle of minimum deviation delta m is given. Okay, 40 degree. Angle of the prism. Okay, it is given 60 degree A. Then what are the factors you need to find? What is the refractive index of the material of the prism? Okay, so direct part only. N is equal to, the formula, sine N is equal to sine A plus delta M by 2 divided by sine A by 2. Okay, now second part of the question. So we can find the value of n here. Okay, then come to the second part. If the prism is placed in water, refractive index is given. Predict the new angle of minimum deviation. So what do you have to do? Prism is placed in water, refractive index is also given. So here, what you have to do? First, you have to take that refractive index like this. Okay, NGW. Now prism is in water. So how much is NGW? NGW will be NG divided by NW. NG divided by NW. That is equal to, again you have the same formula. Okay, sine A plus delta M dash divided by 2 divided by sine A by 2 divided by sine A by 2. Okay, then carefully you have to solve the question. Substitute the value of NG and NW there. You get NGW. Then what you have to do? Cross multiply the equation. Ng into sine A by 2 you have to take. Okay, NGW into sine A by 2. Sine A by 2, A is given, so sine A by 2 value you can calculate. Then you will get sine A plus delta M by 2. Sine A plus delta M dash. Okay, by sin a plus delta m dash by 2. Now what you have to do? Here in the right hand side, that part, you will get the value, and this value you have to search in the sine table. Whatever value you get, you have to search in the sine table. Then you will get a particular value of angle. Okay. Once you get the value of angle, I think you will get around 35 degree approximately. You have to find out the exact value. Okay. Around 35 degree you will get. That value you have to equate with the a plus, to equate with the a plus delta m by 2. Delta m dash by 2. Now by rearranging this, you can find the value. Okay. You have the value of a, so cross multiply and find the value of delta m dash. So that way you can solve that question. Okay, and the values. Then next, question 7. Double convex lens are to be manufactured. Okay, glass refractive index 1.5 with both the faces of same radius of curvature. Okay, so then here, what is that? It's a direct application only. So 1 by, you are asked to calculate radius of curvature. Okay, let's make its formula you have to use. 1 by f is equal to n minus 1 into 1 by r1 minus 1 by r2. 1 by r1 minus 1 by r2. Now, in this formula, you have to take it is this concept you have to take. R1 is equal to R and R2 is equal to minus R. R1 is equal to R and R2 is equal to minus R. So the equation becomes 1 by F is equal to N21 minus 1 into 2 by R. Okay. And from that equation, you can find the value of R. Now, next. Question 8. Question 8 you have to see carefully. Okay. A beam of light converges at a point P. Now a lens is placed in the path of the convergent P, 12 centimeter from P. At what point does the beam converge if the lens is, first case convex lens of focal length 20 centimeter and second is concave lens of focal length 16 centimeter. Okay. Take first case, convex lens. First case, convex lens. Look at the diagram. Okay, so you can have a convex lens. The beam is a converging beam of light. So question says that the beam converges at the point P. At point P converges and that point P is 12 centimeter away. That also question says it is 12 centimeter away convergence. So in that convergent beam only you have placed a convex lens now. You know convex lens is a converging lens. Convex lens is a converging lens. Therefore, what happens? The beam will converge airly. Like this. And what is this distance which you need to calculate? That is what's the question. Now you have to imagine the converging beam. Actually, when the beam converges, an image will be formed here. At B, one image will be formed. Now that image is not formed, but that image will act as the object now. So this is the object for the lens. But there is no actual object present there. Therefore, what type of object? That is a virtual object. That you have to note very clearly. A virtual object is there. As it is virtual object, then you have to take 12 centimeter as u. U is equal to 12 centimeter. But in the case of converging virtual object and converging beam, unlike all other cases, u should be positive. That is, especially you have to note u is positive, and v you need to find out. When you find v, you will get the place where the new image is formed, the v. Okay, and for which f is already given in the question. Okay, f is equal to 20 centimeter plus 20 because it is convex lens. So use the lens formula. Okay, minus 1 by u plus 1 by v is equal to 1 by f. You will get the answer. Okay, so remember in this question, u is positive, converging beam, virtual object, all these points you have to note in this question particularly. Okay, now next, take the case of concave lens. Again, situation is same only. So concave lens, converging beam we can take in this way. Converging beam. On the path, one concave lens is placed, and concave lens is a diverging lens. Being a diverging lens, this ray will be diverged. So this is point P, 12 centimeter from lens. Now the new image will be formed here only. So that will be the final image I, and that distance you have to take as image distance. Okay, and what will be the situation for image distance? Because of the presence of diverging lens, the final image will be formed at I, and that image distance I you are asked to calculate. So again you take a u is equal to plus 12 centimeter. Then f is given, v you can calculate, and here one more point you have to see here for converging beam. Usually you have studied in class 10 and all, diverging lens can form only virtual image, but for converging beam, when you placed a concave lens, it forms a real image. Okay, the image will be real image, while objective will be virtual. A real image will be formed. Image formed is a real image, but here also object is virtual object. Okay, so when the object is virtual, concave lens can form a real image. Otherwise, concave lens can form only virtual image. Okay, come to question 9. An object of size given 3 centimeter, object distance is minus 14 centimeter, focal length of concave lens, as it is concave lens, focal length is negative, concave lens is minus 21 centimeter, find the image distance. Okay, nothing more. Use the lens formula, minus 1 by u plus 1 by v is equal to 1 by f. Find the value of v, then find the value of m. M is equal to v by u. If m is positive, virtual. M is negative, real. Then you can use the formula again. M is equal to s dash by h. If you want, you can find a comparative size of s dash by h, and you can find the comparative size of image also. Then what happens to the happens if the object is moved farther away from the lens? This is a concave lens. Concave lens can form image always between optic center and principal focus. Okay, if the object moves away from the lens, then image moves towards principal focus. I repeat, image moves towards principal focus. Okay, now next question 10. What is the focal length of a convex lens? Sorry. What is the focal length of a convex lens of focal length 30 centimeter in contact with a concave lens of focal length 20 centimeter? Is the system converging or diverging? Okay, so this is a lens contact, and lens contact formula, 1 by f is equal to 1 by f1 plus 1 by f2. Here you have to see f2 focal length is negative, being a concave lens. So substitute the values in this formula and find the value of f, the effective focal length. Then if you get effective focal length positive, then it is converging. If the effective focal length is negative, then it is diverging. That is a concept. Okay, I repeat, if f is positive, converge. If f is negative, then diverge. Okay.